And when we're talking about innovations, now we have a real one. This paper that is going to be presented by Mr. Petr Gnatyuk is I think, a groundbreaking paper because introduces a total new philosophy in the seawater chlorination and in the post-water chlorination. We are suffering a lot about biofouling, and the introduction of mixed oxidant can be really a complete game changer in the industry. So it is my real pleasure to introduce the innovation in Site 4, mixed oxidant on-site synthesis for cost-effective seawater and potable water disinfection by Mr. Petr Gnatyuk, founder and CEO of EMERALD Technology. Peter, welcome on the stage, and we're looking forward to your presentation.
Thank you. Thank you very much. Dear colleagues, hello. Thank you very much for the ability to make a speech at so respected event. Thank you, Mr. Corrado. So our company, EMERALD, we are manufacturing electrochemical systems. It is electrolysis in the core of it, but it is the new level of electrolysis. We have more than 50 years of experience in this technology, and I would like to share the core things which will be interesting for all of you. The main materials which we use is salt, pure salt, and water, and power. And we are capable of producing chemicals to eliminate any type of disinfectant which are used now for seawater chlorination, for potable water, for wastewater. So let me start with the main drawbacks of the traditional disinfectants, which are aware for you. So the idea of this table is to show that monodisinfectant, a single one, cannot solve all the issues related to the water disinfection. Because one of the reasons, microbes, they are living beings, and you cannot kill living by the dead chemical. Because monodisinfectant, it is a dead thing, and microbes will always find a way to adapt to it. And that is why sodium hypochlorite, for example, when you make continuous chlorination, it becomes less and less effective. So the three main chemicals important for the Middle East, chlorine gas, the drawbacks of it are quite aware. It is dangerous, it produces triglycerides, haloacetic acid. Sodium hypochlorite, it is very weak disinfectant, it is known. You have always chlorine degradation. For example, you buy 14%, but at the time when you dose it, it is 9%, especially at hot air conditions. It forms disinfection byproducts, and it gives the sludge inside the pipes. So you have to stop the system to clean it, and so on. Chlorine dioxide is a better solution, but you know it is very expensive because of you need to buy sodium chloride, and it also produces chloride and chloride in water. And the new fact, which has turned out not so long ago, and is now proven by the main off-takers in the region, that chlorine dioxide causes the damage of HDPE pipes because of hot water and chlorine dioxide in it. Before, there was no such issue with chlorine gas. So our solution is very simple. We can produce the chemicals on site from water and salt, and the core economical terms is that we can reduce the OPEX, operational expenditures, by 60–90%, and it will give the return on investment around 1–3 years. I will dwell on it a bit further. So the concept of the system is that we are now the only company in the world, in the electrolysis world, capable of producing mixed oxidants. So the main one is hypochlorous acid. It is, you know, like a king, which makes the main job and gives you very good active chlorine residual. But at the same time, you have hydrogen peroxide, oxygen, ozone, chlorine dioxide. These fast reactive species, they enable chlorine to work better. Especially in terms of disinfection byproducts. We have made a lot of comparison tests. When sodium hypochlorite or chlorine gas alone, it produces bromate, and our solution, it does not produce it. So this is the main concept, and in terms of biocidal activity, you have a synergy effect. Because of a variety of oxidants which are freshly produced, you have a very strong biocidal activity against any known types of microbes. The structure of the cell consisting from the anode chamber, cathode chamber. So as a byproduct, as additional byproduct, we also synthesize caustic soda solution, which can be effectively used for desalination plants for pH plus correction and as a flocculant. This is the structure of the cell. We are making all of it on our facility. So we are making the coating of the anode with iridium. We are producing our own membrane made from ceramics. And we give 5-year full warranty for electrochemical block, because we know that it will work more than 10 years. This is just a real photo of one of the assembling unit and the real way how the machines look like. So each machine can produce up to 3 kilograms of active chlorine per hour. We measure our oxidants in active chlorine, and it can be measured by the same sensors to measure active chlorine as you use for sodium hypochlorite. In 30 years of this machine, we have produced more than 1,600, which were supplied for municipal treatment, for sewage treatment, for swimming pools in various countries. We have all the European certificate for this technology. Yeah. And now we will add this solution to this table, and you will see that because of the synergy, we can fill all the necessary requirements connected with the disinfectants. And the upper line, it is the OPEX comparison between traditional disinfectant and this system. And you can see that only chlorine gas can somehow compete in terms of OPEX with this system. All other are much more expensive, and I will prove it further. So our real practice in the Middle East says that comparing to chlorine dioxide for potable water disinfection, we can reduce OPEX by 90%. It was confirmed by the calculations at NaCl desalination plant in Amal Quain. Comparing with sodium hypochlorite, we can reduce OPEX by 60%, and it was confirmed by the tests at Dubai municipality Jebel Ali station. So in its turn, replacing the chlorine dioxide system gives you the return on investment around 1 year, and replacement of sodium hypochlorite gives you return on investment around 2-3 years maximum. Because the technology is quite efficient, we have enabled to reach the lowest levels of consumables. So per 1 kilogram of active chlorine, we consume only 1.8 kilogram of salt and 3.85 kilowatts of power. This is minimum 30% less than any other companies producing traditional sodium hypochlorite on site. So the OPEX for 1 kg of these chemicals is around $1. This one I will skip. This is a bit detailed things about this technology. I will focus on the biofilms. So we have proven that this technology, these oxidants, can remove biofilms from the inner surfaces of pipes, which is very important. So you see the yellow tube, which was covered with the biofilms inside, and just in 1 month after we start dosing 0.1 ppm only, we have eliminated the biofilms from the tube. This is another example in the USA project. The pipe, the quality is not good because it was not so suitable to photo. But this is the first pipe where the biofilms worked on sodium hypochlorite disinfection. This is the pipe in 6 days after shifting to 0.2 ppm dosage. And this is in 22 days. You see the pipe is completely clean. And this is one of the main things. When you clean up the pipe from the biofilms, you will be able to get very stable active chlorine residual in all your distribution network. In ecological terms, this equipment can really do a real revolution, because from 1 truck of stable salt, you can synthesize approximately 8 trucks of sodium hypochlorite equivalent and 2 trucks of caustic soda equivalent, which are bought on the market usually. This is an example of how brine making system can be made. this is a vertical brine maker, so you deliver the salt by the truck, and the brine making solution is made automatically for the system. So the only thing which you should store is a salt, which is quite safe. This is an example of the system in the USA. This is in Kazakhstan, the sewage treatment. This was the quality of the effluent with sodium hypochlorite, and on the right, this is the quality with our oxidants. We didn't change any filters just because of changing of the disinfectant. This is the first project in Russia, in Balakova, first our big project. The system, it is not beautiful, but the system has been working 18 years now, and it disinfects per day around 350,000 cubic meters. The total capacity in active chlorine, around 900 kg of chlorine. And this is the modern way how the machines look like today. So it is more beautiful and more reliable, because now we have achieved that we don't have to clean our cell for more than 1 year. We have made automatic procedures for cleaning up the cell, so we don't have to clean them for more than 1 year now. And very quickly, the main projects which we're doing now in the Middle East and the economic feasibility of this project. The first one, we are doing big project with Dubai municipality. The concept of the project is to replace sodium hypochlorite at the main stations, Jebel Ali and Al Warsan, because they buy around 90 tons of sodium hypochlorite, and the effect of the sodium hypochlorite in the network is not sufficient. You have the smell because of the biofilms and so on. So this will be the layout of the system, producing 12 tons of chlorine per day. It's quite big, but it will cover only 500 square meters. This is the detailed calculations which were given for any of the project. And the summary is that, sorry, it does not want to click. The summary is that for this project, we can reduce operational expenditures comparing with sodium hypochlorite by 55%. It will give savings of around $3 million per year. The second big project in potable water is NaCl desalination plant in Al Quwain. Here, our goal is to replace chlorine dioxide, which is used for drinking water disinfection. The system here will be smaller. It will be supplied in 20 feet seawater containers, so quite easy to maintain and install. But the fantastic things which were revolutionary for us, that we found that we can reduce OPEX comparing to chlorine dioxide by 91%. And it gives the return on investment of around one and a half year only, while the system is designed to work 20 years. So, just finally, I will show you a very interesting video and make some comments on it. It is working. Yeah. This is just a chemical simple test. It is hydrochloric acid concentrate. This is sodium hypochlorite concentrate, 12%, and our mixed oxidants on the right. Only 0.1% in active chlorine. We add ink, because the dye in ink, it is very complex organic compound. It is very difficult to oxidize. And look the difference of oxidation speed between sodium hypochlorite and mixed oxidants. So our solution, because of the synergy effect, it oxidizes the ink, which is very difficult, in 4 seconds. Sodium hypochlorite concentrate, 12%, makes it in around 7 minutes. So the active chlorine concentration here is 120 times more than here, but the speed of reaction is around 100 times faster with our solution, because you have a synergy and because they are only freshly synthesized. Thank you very much. This is all for me. I hope it was interesting. If any questions, I will be glad to answer. Thank you.
EMERALD, nature-like technologies at human disposal.